right, well, welcome to your back to your favorite intermediate algebra course. We're going to look at factoring and solving polynomial equations. So, if you remember, we've done some factoring before with like quadratics. Okay, like let's take 3x squared plus 11x plus 6. You look at that first term, you say, well, it's got to be 3x, x. Those are my factors of that, right? I look at the 6 there, and I'm like, well, it's got to either be 2 and 3, or 6 and 1, and you pick that, and you're like, well, let's try. Oh, I don't know. Let's try 2 and let's try 3, right? And then you look at the sign there, and you're like, well, it's got to be either positive times a positive or negative times a negative, because when I FOIL it back again, this 2 times 3 must give me a positive 6, right? Well, let's try a plus and a plus. And then, of course, you FOILed it and you checked it, and you said, well, let's check here. 3x squared. We got a plus 9x. We got our plus 2x here, and we got the plus 6 right here. Oops, that's 2x. So 3x squared plus 11x plus 6. You say, oh, that was it. So here's my factorization. 3x plus 2 times x plus 3, right? So we've done that kind of factoring before. Now there's some special factoring patterns that we have, okay? Like, here's some special, oh man, that's so bad. So a cubed plus b cubed is one of those. So if a cubed plus b cubed is what you're trying to factor, you know one of the factors is a plus b, and the rest of it is in the form a squared minus ab plus b squared. Okay, so that's one of your special factoring patterns. I'm going to show you why you don't necessarily have to memorize this. Here's your other one. But you can if you want to, okay? So if you're factoring the difference of two cubes, a cubed minus b cubed, a minus b, a squared plus ab plus b squared, okay? So for example, let's take a look at x cubed minus 64, okay? You notice how it fits this form, a cubed minus b cubed, okay? So one way that you can remember this, or that you can do this without having to memorize that it works out to be that exact pattern, okay, is you say, okay, 64, is this a cubic? Yes, it is. 4 cubed is 64, right? So you see how your a is x and your b is 4? So you know x cubed minus 64 is going to, one of its factors has to be x minus 4. Okay, and then you just got to figure out the rest. Okay, so the a is the x, the b is the 4. Okay, and then again, you don't have to memorize a squared plus ab plus b squared, because we know from last section, if you want, you can just do the division on that, right? You can do the division. You say, well, x, or you know what, let's do synthetic division. So our k here is 4. I'd have 1x cubed, 0x squared, 0x, and a minus 64. And you do the division and you get your answer. By the way, you should get no remainder on this because you know x minus 4 is a factor, right? It's a clean factor, if you will. So you got 1x squared, 4x plus 16, right? It's 1 degree less than that x cubed. So that's why we start with 1x squared. Squared plus 4x plus 16, okay? And then you look at that x squared plus 4x plus 16. You see if this one, does this factor any further? It doesn't, so you just say, oh, there it is, completely factored. Okay, so that's how you factor x cubed minus 64. Okay, let's do another one about, let's go with, let's try that one. 8x cubed. You know what, let me go with a plus 27. Let's go ahead and factor this. 8x cubed plus 27. You notice how this fits the form a cubed plus b cubed again, right? a cubed plus b cubed. So this is really, you know how 8 is 2 cubed? So it's really 2x cubed plus 3 cubed, right? So you know 8x cubed plus 27, one of its factors is 2x plus 3. You know that for sure, right? And you can do the division on the rest of this. Now, you remember how synthetic division only works with something of the form x minus k? You see the 2 right there? That kind of messes things up, right? So don't use synthetic division here. Don't use synthetic division. You're going to have to use the polynomial division. 8x cubed plus 0x squared plus 0x plus 27, right? You go ahead and you divide that by 2x plus 3. So that's going to end up being, you say what times 2x, 8x cubed. You remember we did this last time. 4x squared times 3, 12x squared. Change. What times 2x gives you negative 2x squared? That's a negative 6x. Can't see. Okay. Change, gone, remainder 0. So that's where, see that 4x squared minus 6x plus 9, so that goes right there. Okay. Which is a squared minus ab plus b squared there at the end. Okay, if you're also, again, you can follow the pattern, or, this is how I prefer to do it. I like to just do the division, having recognized that one of the factors. Okay. Let's do some more. What if you're factoring something like, let's say we got 54y to the 4th plus 16y, okay? So you're looking at those two terms. Now, if you can take something out of each of those, go ahead and do it right from the beginning. So you say, oh, I can take a 2y out of each of those, and then I'd be left with 27y cubed plus 8, it looks like. See how if you distribute that back, you got 54y to the 4th plus 16y. And then this is the sum of cubes, right? So you know one of your factors is going to be 27 is 3 cubed, so it's going to be 3y plus 2. And then you just got to figure out the rest of this, right? 3y plus 2, so you go to the side. And you take 27y cubed plus 8. Let me erase this part. Take that 27y cubed, 0y squared, 0y plus 8. And you go ahead and you divide it by 3y plus 2. And in this case, you actually end up with 9y squared minus 6y plus 4. That's what that's going to end up being. And that's where you put it right there, 9y squared minus 6y plus 4, okay? So there's your complete factorization. You got 2y, you got 3y plus 2, 9y squared minus 6y plus 4. Okay, there it is, completely factored. All right, let's go back to factor by grouping now. Okay, factor by grouping. Now this oftentimes occurs when you have like 4 terms. Okay, so how about x cubed minus 3x squared minus 4x plus 12. Okay, see how you got 4 terms there? So you take a couple at a time. You say, okay, let me look at these two. What can I take out of those two? What's their greatest common factor? I say, well, I can take out an x squared on each of those, and I'd be left with x minus 3. See how if you distribute that back, that's x cubed minus 3x squared. And then you look at those two, and you say, well, what could I take out of those two? I could take a 4 out, right? I could take a 4 out, and what would I be left with? I'd be left with a negative x, and then I'd be left with a plus 3, right? Yeah, that's a negative 4x plus 12. Now, see how we've been reduced to 2 terms, right? When you're factoring by grouping, you want to have a greatest common factor from each of those terms. You notice that you don't, right? But you're really close with that one. If I could force that to be x minus 3, I want to go ahead and do that. Okay? So instead of taking a positive 4 out, why don't we take out a negative 4 instead? Okay? What if we take out a negative 4 instead? What's going to happen? Well, that inside there is going to be a positive x and a minus 3 instead. Okay? X minus 3. See how if you distributed that back? See how if you distributed that back, you'd have negative 4x plus 12 there? Okay, now look at the two terms. What do those two terms have in common? They both have an x minus 3, don't they? Okay? So I go and I say, oh, okay, they both have an x minus 3. See that? Take an x minus 3 out. Think of that as taking one quantity out, right? And then what are you left with? You're left with x squared minus 4. X squared minus 4. Okay? So think of that x minus 3 as one quantity. It's just like if you had like 3xy minus 2x. And you have these, see how you have these two terms, and if you take an x out, you take an x out of each of those, what are you left with? 3y minus 2, right? Same thing, except in this case, our x is actually the quantity x minus 3 on the left-hand side, if you will. Okay, so this is factoring by grouping. Now, if I can go further with this, I will. So x minus 3, and think of that x squared minus 4, that's the difference of squares, right? X minus 2 times x plus 2, when you FOIL that, gives you that x squared minus 4, if you remember that difference of squares. Okay? Let's do another factor by grouping. Factor by grouping. How about, extend this a little bit. All right, let's take a look at this one. Again, take a look at the first two, and I say, well, what's the max that I could take out of each of those? How about negative 2x squared? What would I be left with? X plus 2, right? If I distribute that back, I get negative 2x squared. I'm sorry, negative 2x cubed, and I distribute that to the next one, I have minus 4x squared, right? Now I'm looking at these two, okay? What can I take out of those two? How about a negative 3? Okay, and if I do, I'm left with x plus 2. Notice if I distribute that back, I got negative 3x minus 6, right? Now I got to take out negative 3, not positive 3. I got to take out negative 3. Otherwise, in this and this, I won't have the same x plus 2 there, right? So I gotta force it to have the same thing and a common factor in each of those terms. So I go ahead and I take out that x plus 2. Take out the x plus 2, right? So I'm taking this whole thing out, right? And I'm left with negative 2x squared minus 3. Negative 2x squared minus 3. And I say, can I go any further with negative 2x squared minus 3? I cannot, so I'm stuck right there. Okay, so we just stop right there. Okay, so that's factoring by grouping. Factoring by grouping. All right, let's continue on. Let's do some factoring when you are quadratic in form. Factoring polynomials that are quadratic in form. Okay, for example, let's take a look at, how about 16x to the fourth minus 1. Now, if you remember we already talked about difference of squares. X squared minus y squared is x minus y, x plus y, right? Difference of squares. So if you look at this and you're like, wait a minute, isn't 4 squared 16 and x squared 4, right? In other words, this could be rewritten this way. And 1 squared is 1, of course, too, right? See how it fits x squared minus y squared? So this is quadratic in form. It's just like the difference of squares. So you have 4x squared, 4x squared right there. You know it's got to be 1 and 1. You know one of them's got to be a minus, one of them's got to be a plus. Of course, you FOIL it to make sure that that works, right? In fact, let's go ahead and FOIL it. We're like, hey, that's 16x to the fourth. That's a plus 4x squared. It's a minus 4x squared right here. And finally a minus 1. And you see how those cancel? Hey, that works. 16x to the fourth minus 1, right? Now, we're not all the way done with this because this one is a difference of squares itself. So that's 2x minus 1, 2x plus 1. And of course, we still got this 4x squared plus 1, which we're stuck on that one. That will not factor any further, okay, unfortunately. So that's a quadratic in form. Let's look at some more. How about 2x to the 6 minus 10x to the 4th plus 12x squared. Okay. Now, if you're looking at this one, whoa, and you're like, whoa, I got this x to the 6. What in the world am I going to do here? Well, take out a greatest common factor from each of those. You're like, I can take out a maximum of 2x squared from each of these. And it looks like I'd be left with x to the 4th minus 5x squared plus 6, and go ahead and distribute that back. That would be 2x to the 6th, minus that 10x to the 4th and plus 12x squared, right? So now that you're left with that x to the 4th minus 5x squared plus 6, you say, is that quadratic in form? Can I keep going with that? Can I keep going with that, right? I say, well, factors of 6, and remember it's going to be either plus plus or minus minus. So it's either minus 2 minus 3 or plus 2 plus 3. It ends up being minus minus. Again, you distribute that back to check that. And you stop right there because you cannot go any further with that x squared minus 2. You can't go any further with the x squared minus 3, at least if you're leaving it in that where the 2 and the 3 are integers anyways. Okay. All right. Now, the factoring all leads us into what we always love to do, which is solving equations, right? So let's go into solving a polynomial equation. X to the 4th plus 4 equals 5x squared. Well, we have this original equation. Step number 1 is we want to get this equal to 0. So force it equal to 0 here. So we got x to the 4th minus 5x squared plus 4 equals 0. We're going to go ahead and see if we can factor to solve this, right? Since we've been learning that this section. I say, yeah, this is quadratic in form. X squared, right? You got that factors of 4. Well, I'm going to try 4 and 1. 2 and 2 is not going to work for you. It's either got to be a negative times a negative or positive times a positive. Negative times a negative is the one that works. You say, can I go any further with this? Sure, that's difference of squares. Can I go any further with that? Hey, there's another difference of squares. Remember, we have this equal to 0, don't we? And now we apply the zero product property. So to use the zero product property to finish this thing off, right? Let's say, oh, that means x minus 2 could be 0, x plus 2 could be 0, plus 1 could be 0, x plus 1 could be 0. Of course, we solve each of those. That would be negative 1, that would be 1 when we add both sides, that would be a negative 2, that would be a 2. Okay, so all our answers, well, here they all are. I'll just circle it. Oh. Okay, negative 2, 2, negative 1, 1. Okay, those are all our solutions to that original equation. Oops, looks like I went a little overtime. May end up splicing this. But anyways, let's do a polynomial equation um, application here. Okay. Let's say we have this rectangular swimming pool. Okay. Um, you guys don't want to see me drawing here. Okay, something like that there. It's a little ugly. Anyways, we got this rectangular swimming pool. Okay. And this thing has a volume of 512 cubic feet. Okay, cubic feet. And we'll say the pool's dimensions are it's x feet deep x feet deep, and let's go 6x minus 8 feet long, 6x minus 8 feet long, and 6x minus 16 feet wide, 6x minus 16 feet wide, okay? And if you remember, and we're looking for how deep is this, you know, question is how deep? How deep is this pool, right? What's that x right there? Well, if you remember, volume is your, you know, your length times your width times your height, right? And so we're just going to go at it. Our length here is 6x minus 8. Our width is 6x minus 16. And our height is x, right? And we know this volume is 512, okay? And then we just go through this little by little. Take that first, and we're going to get, and then we multiply that x through. Let's see, 36x squared. Oh, what's 16 times 6? 96, so minus 96x minus 48x, and then 16 times 8 would be, oops, 128 plus 128, and then don't forget to take that x through to all of that. Okay, so take the x through to each of those, 36x cubed. Of course, I'm going to combine those before I take the x through to that. So what's 96? 96 and 48. Oops, 144. So minus 144x, but I got to multiply by that x on the outside, right? And then plus the 128x. So we got this 36x cubed minus 144x squared plus 128x. And then I got to get one side equal to 0. So let's go ahead and subtract that 512 right now. Subtract the 512 so that we actually end up with 0 here, right? So 0 equals 36x cubed minus 144x squared plus 128x minus 512. Let me extend this. Okay, and you're like, well, gosh, I got, at least if I'm going to do this by hand without a calculator factoring it for me. I'm taking a look at this, I'm like, boy, I got to take out a couple of things from each of those, right? What could I take out? Well, actually 36x squared, I believe, goes into that. With that, distribute that back, check that, yeah, that's 36x to the third. 36 times 4 gives 144. Okay, and then over here, you can take a 128 out of that, and you'd be left with x minus 4 there. 128 times 4 is 512. Okay, and you say, oh, hey, on these two, do I have a common factor there? Sure, that x minus 4, right? So I'm going to take an x minus 4 out, and I'm left with 36x squared plus 128. Okay, 36x squared plus 128. And then we keep going with that, right? And so and you look at that 36x squared plus 128, you can't factor that thing any further. So you apply the zero product property right here. So you have x is 4, and then when you go to solve that 36x squared plus 128, you know, that ends up those are when you, I'll just do it here, sorry. Let me extend this page here a little further. See how you have x squared as some negative number, right? So when you take the square root, you're going to have non-real solutions, right? You're going to have some complex solutions here. Imaginary number, sort of like, hey, that can't be it. It's got to be 4 feet, right? Go back up to the top. You say, was that what I was looking for? Was it the height that I was looking for? The depth there? Yeah, 4 feet. Okay, so as I say, whoops, that's it. X is 4 feet. Okay, X is 4 feet deep. Okay, all done. Thanks for watching. See you next time.